Next, we're going to turn our attention to the data persistence layer. You'll remember that in a modern web application, we've got kind of three basic tiers or three basic layers to the layer cake. At the bottom is the data persistence layer, which is basically how do we store data that's used by our application in a database. The middle layer is what we've been calling business logic, or maybe more generally application logic, because it doesn't have to just apply to a business application. And then the top layer is the user interface layer that gives access to the other two layers to mere mortals that are using our app. Since the database that we'll be using in this course is a relational database that we're going to access with the SQL language, we want to talk about a piece of software that allows us to make the construction of those SQL queries a little bit easier, a little bit more portable. So this is talk about the SQL Query Builder, or a SQL Query Builder. So by way of introduction, there's kind of two ways that we might interact with our database from inside of our data persistence layer. One would be to write SQL directly, and there's a variety of different interfaces for that from different host programming languages. And the other is using a query builder, and that's a sort of a separate piece of software that makes it a little more straightforward for us to create those queries without having to go into all of the details of the SQL for the particular database that we're employing. And I want to just give you a little bit of sort of pro and con analysis of these two options. So for the notion of using direct SQL, one advantage of that is that there's probably not a huge learning curve for most of the kinds of queries that we might want to write. You're already familiar with some aspects of SQL, and by using SQL directly, you can leverage that knowledge. And that's not going to necessarily be true for a query builder in the sense that you've got to learn a new approach to doing SQL. The query builder that we're going to employ in this course is actually based on JavaScript, as is all the other programming interfaces that we're going to be using. So although you already know JavaScript, you have to basically learn the API for this library that knows how to build queries based on the JavaScript that you put in. So there's a little steeper learning curve, which is a slight disadvantage. Another issue that you want to take into consideration when you're thinking about how to actually access the database is whether you need to be able to remain relatively independent of the specific database management system. That's what DBMS stands for. When you write SQL directly in the dialect of the language that's supported by a particular database management system, you're sort of locked in a way to that particular implementation of SQL. That claim might surprise you a little bit in that SQL is essentially a standard language for interacting with relational databases. But what you find is that the vendors of the database management products that you're going to encounter out there are going to implement the SQL standards to a greater or lesser extent. And they're also going to exhibit a strong tendency to want to kind of customize SQL to their own purposes. So there's fairly broad overlap between implementations of the SQL language from database vendor to database vendor, but it's not a seamless transition if you want to go from one database to another. So one way to kind of ameliorate the challenges associated with having to port from one database to another database if necessary is to use a query builder that hides all of the specific details for a particular database management system. In our case, your JavaScript code doesn't really have to change at all, but the query builder itself knows how to take your JavaScript function invocations and turn that into the appropriate dialect of SQL for the database that you're using. It's also helpful to have this kind of flexibility when you're doing development on a new system. Rather than having to use a complete full-on production database that's going to eventually be the environment on which your application runs, it tends to be sort of clunky and hard to connect to and probably protected by a bunch of security and just generally difficult to use. You might actually choose to use a simpler database management system that also does relational databases but doesn't come with all that extra baggage associated with it. So for example, many of you are familiar with the SQLite database, which is an amazing little database program that basically runs a complete relational database in a single file, implements a very large chunk of the SQL standards, and just runs as part of a process on your laptop even, or your development workstation. Really super helpful, convenient way to store data as you're doing development on a new application. But it is not compatible in general with sort of more large-scale production quality relational database management systems. However, if you're using a query builder, you just interact with the query builder and it knows how to speak SQLite, for example, during development, and then when you want to switch over to your production database, your database access code is going to run basically unchanged on that new system. Another criterion that you might want to think about when you're choosing the appropriate way to access your application data would be tooling. So for example, tooling compatibility in particular, right? When you're looking at the development environment and the kind of tools that you're going to use to do development, it can be helpful to have tools that are compatible from one environment to another, so you're not learning 5 different ways of accessing your database. What you find in some cases is that if you're using a particular database product, you're going to use the tooling from that particular database vendor, and that's not going to be necessarily the same as tooling from some other vendor. Now, there are packages that are kind of cross-database, and in general, they work pretty well. I prefer a cross-database tool called DataGrip from the people at JetBrains. Works really great to talk to different kinds of databases, but you're not going to really get complete integration with the particular vendor's database that you're going to be using if you're using a general purpose tool. On the other hand, if you're using a query builder like what we're going to do, it's just JavaScript. So you can write JavaScript in a lot of different tools and apply it to a whole variety of different databases. Finally, different paradigms for development, and this is a little bit more abstract. When you're writing SQL directly, you have little choice but to write SQL. But if you're using a query builder, like even the one that we're going to look at in JavaScript, you could write more imperative code, you could write functional code, you could write object-oriented code, kind of use different development paradigms that fit with your particular project, your particular team, your experience level, or your knowledge of particular technologies. Going to have a lot more variability and flexibility to use different coding paradigms in that query builder context. So some pros and cons you might want to keep in mind for these two approaches. We're going to take the second and look at a query builder here. This is the query builder we're gonna use in the course. It's called Knex.js. If you're familiar with the Knex building system, I have no idea how the Knex people have avoided running afoul of some sort of copyright or whatever, but that's, at least the last time I checked on their homepage, was their logo. So this is the name of the package. It's obviously a JavaScript package that runs in the Node ecosystem, and it allows us to write code that is independent of any particular database and then adapt it to use a specific relational database management system. These are some of the key features of Knex. First of all, it's got very broad support for different database systems, both open source systems and commercial ones. So I've listed just a subset of some of those. I mentioned SQLite is a great little development time database. We're actually going to be using Postgres or PostgreSQL for this course, but it supports all these others just as well. In terms of that kind of multi-paradigm programming, Knex supports both callback style usage and promises, which means we can either use promises directly or we can use async await when we want to do asynchronous code with the database. And again, this is another area where we really do want to leverage asynchronous JavaScript, right? We just like when we go out to the network or when we go out to the file system, that's a relatively long-running operation that we don't want to use a blocking kind of a synchronous mechanism for coding that. We want to run our database queries asynchronously. So the fact that Knex supports callbacks and promises is right in the sweet spot for doing that. It allows us to build both queries, either select queries or the other parts of the CRUD pattern, right? CRUD being create, read, update, delete. We can insert data, we can update data, we can delete data, we can choose or we can select data to read it from inside of Knex. So that's kind of the query side. Knex also has a schema builder, so we can program in JavaScript to tell the database how to create new tables, how to create relationships between tables, how to update existing tables, and so forth. So we can use that for both schema maintenance and for writing the queries themselves. We'll see that Knex supports transactions, which is an important element of getting a database management system to work correctly. A simple way of thinking about transactions is in the context of, say, a bank application where you want to take funds out of your savings account and put it in your checking account. You want to have both of those things happen and not have something go haywire between the time you take the money out of your savings account and deposit it back in your checking account. So you wrap that all up in a transaction so that it either all happens or nothing happens. We'll talk more about that. Knex also supports the notion of connection pooling. What we'll see is that when we access a database like Postgres or like any of the production level databases that we just see at the top of the page here, normally the way you do that is to make a connection over the network using TCP/IP, and those connections are limited resources. You can only have so many simultaneous connections open to a database management system at a time. It's usually a configurable parameter, and depending on the level of capability of your hardware servers and so forth, that can be greater or less, but it does have a fixed limit. So it turns out to be handy for your database access code from the clients that are talking to the database to be able to pool those connections, reuse them, and just generally manage that scarce resource. We'll see that there are standardized ways of getting information back from the database that's kind of normalizes the types of responses that you might get from different SQL dialects, which is really helpful for our code. And then finally, we'll see that Knex works really well with our object relational mapping layer. Within the database layer that I've been talking about, we're going to have several sub-layers. There's the database itself, and then there's going to be the query builder that knows how to create the SQL, but that query builder is going to be used by an object relational mapping tool that allows us to convert the tabular structure of a relational database into the object structure that's used more natively inside of JavaScript. So Knex works great with our ORM, which is called Objection. A few notes here about how to install Knex in the development environment. So there's two packages that are important here. One is Knex itself, which is just called that. Because Knex supports a variety of different database management systems, the specifics of that particular database also need to be part of your development environment. And in our case, we're using the Postgres database, and the node package that has the Postgres drivers in it is called PG. So we need to install both of those modules. We'll be programming against Knex, but Knex is going to be configured to connect to the database by using this additional layer between itself and Postgres proper. So Knex is going to make calls to that PG library, and that's the library that's going to communicate over the network to talk to the database. So assuming that these two modules have been installed in our development environment, this is the code that we're going to use to actually make the connection between our environment, our client that's going to use this database, and the database itself. So first of all, we're going to bring in the Knex module, and we're just using the standard node style require statement there. And that's going to bring in what I've given a name here, the Knex module. So that's kind of the top level object that we're going to use to configure our Knex connection. And in order to set that up properly, we need to give this Knex module an object. You can see that it's basically the body of this whole slide is a configuration object that tells Knex how we want to hook up to our database. And this is actually a pretty common theme that we're going to see throughout the course, is that when we're creating these new modules at runtime, we're going to have to give them configuration information to give them some instructions about how we want them to behave. It's more of a declarative approach where we're just basically saying, here's the parameters, you go ahead and take care of the details, as opposed to a procedural approach where we are setting up individual connections and doing TCP/IP stuff and that kind of stuff. Much simpler in this configuration-oriented design. So there's a couple things that we're passing to this Knex module function. The first one is the client type, and you can see that this is a string that says PG. Now that corresponds to the name of the driver module that we loaded in to talk to the Postgres database. So we have to install that software in our development environment, and then we have to tell Knex, hey, that's the driver that we're going to use to talk to our database. Because, as I said before, this is all taking place over a TCP/IP network connection, we need to give some connection details to Knex as well to tell it where to go and make a connection. So we're usually going to supply a host name. Here I'm just running on my local host, so 127.0.0.1 is the same IP address as just the local machine on which I'm running. I need to give it a user name, and on my local machine it's just my name. and then the name of the database. And this is a little bit of a misleading term in the sense that we're talking about a database management system. In Postgres' case, the database management system can actually host a number of individual databases. So the manager is capable of dealing with more than one database at a time. And I've showed the DVD rental database that we've been talking about on and off throughout the term. Another parameter that's often going to be sent along here would be a password to make the connection to the database of interest. And we'll see when we start doing labs that the host name that we'll use is actually going to refer to a server on campus, unless you want to install the databases on your local machine, and then this local host name would work just fine. But at the end of the day, we're really just providing some sort of easy to know, easy to understand, easy to remember connection information, so that when this function is done, the Knex object that comes back is kind of set up to talk to that particular database and do all of the other commands that Knex knows how to do for us. So now we'll start taking a look at what kinds of queries the Knex library can build for us. So here's our first example. We're using that Knex object here, and that's exactly the thing that we got back from this Knex module invocation. So after this Knex module function runs and makes the connection to the database, we have that object that we can use to run various methods on to interact with the database programmatically from inside of JavaScript. What we're doing here is we're creating a select statement, and you can see that we're starting with that Knex object, and we're calling a method defined on that object called select. And you can see here that the method names that are defined inside Knex are inspired by the SQL keywords that do similar jobs. So we're doing a select. We're going to select from a table called country, and we're going to provide a where clause. In this case, we're going to say we want to have the name of that country equal to Thailand. So those lines, these three in particular, as methods of the Knex object, are going to be responsible basically for constructing a SQL query that could be issued to Postgres to be able to fetch back the information about Thailand that's stored in the DVD rental database. At this point, though, once we get to this line in the code, we haven't actually issued a command yet. We haven't sent a message over to Postgres across the network to actually fetch that information. We've just used it to build the query. And that's exactly the idea here behind a query builder. We're going to construct the query, but in this particular case, we haven't executed it yet. Now, one of the things that you find is helpful when you're first getting used to using a query builder like this is that you kind of want to be able to leverage your knowledge of SQL to be able to understand if you're invoking the query builder in the proper way in order to generate the SQL statement that you think you're going to generate. And Knex provides us with a helpful function called toString. And what that does is it takes the information that's been given to Knex so far in these other statements and actually constructs the SQL query and just returns it back to us as a string. So there's nothing in this little block of code that's actually going to hit the database. In fact, what's going to come back from this chain of method calls and get stored in this SQL variable is actually the query itself that's been built up. And so the last statement here, just console logging that string, gives us this output. And you can see select star, so from country, that's what came from the country clause. Where country equals Thailand comes from the where clause. And the select star, you can see that the star, of course, is the general purpose, give me all the columns that are in that query. And that's the default that's used by Knex when we don't give any arguments to the select function. So that comes from the select method. So you can see that these three lines, select from and where, are directly responsible for creating these three clauses of the SQL statement. And in this case, we're not executing the query, we're just echoing it back as a string to make it something that's easy for us to understand and debug and just sort of understand exactly what's going on under the hood behind these calls. Now, it's not really evident so far that this is really that helpful, right? There's actually more typing involved in running this code than just making that SQL statement. However, as I said before, we gain an ability to be relatively independent of the database. So for example, in this case, SQL or PostgreSQL has a convention that in some cases you need to put double quotes around column and table names if they have sort of a complex internal structure, if you're using different upper and lower case letters and stuff. If you're writing that query directly, you just have to sort of learn and memorize that convention and use it on your own for all of your queries. Other databases might not have those same kinds of requirements around quoting table names. The other thing here that's going on is that this string Thailand, this literal string, is using single quotes instead of double quotes. And that's actually part of standard SQL, that strings are to be single quoted, even though in JavaScript we can use single quotes or double quotes or back quotes, in fact. But again, that's a detail that you've got to learn to be able to write syntactically correct SQL statements. And when you move from one database to another, there might be another learning curve you've got to climb in order to get used to the specifics of that new dialect of SQL. Whereas in this case, we're writing totally generic JavaScript code, and because we've configured our connection, back here again, right, we've told it it's going to connect to the Postgres driver, Knex realizes that it's generating output for PostgreSQL, and it applies all of these Postgres-specific kinds of quirks that make up the syntactically correct SQL to issue to the database. We don't have to worry about any of that at all. Another helpful function that you can call in the Knex object to help you debug a query is, instead of toString, something called toSQL. You can see here that this is the same basic query, select from country or country equals Thailand, and then I'm calling toSQL, so this variable SQL is going to be assigned to whatever this toSQL function returns. And then I'm logging that out to the console, and you can see that it gives us kind of some more information about what's going on under the hood. We can tell that it's a select method, that there's no options being passed, and we can also see this thing bindings here to say that we're binding Thailand into the process. It also shows us the SQL statement itself, and actually this helps us understand what that binding is. You'll notice here that when we see the SQL statement, it uses where country equals question mark. And that's a common capability in SQL that allows us to avoid SQL injection attacks. Basically what we're saying is we want to have some value passed in there for the specific match of the country. We don't want to allow for any value to be pasted in there in case we're dealing with a nefarious end user who might have typed something into a field in a form, and that might have made its way through our code in such a way that it would be directly added to this query. Instead, we're going to take the information that we might have received from an end user and use it as a binding, and what will happen is that the SQL driver will make sure that even if this has some nefarious SQL commands in it that might cause us to lose data, that those commands are kind of sanitized before being plugged into the query itself. So this is a way of kind of protecting us from those kinds of problems. And it's reassuring to know that the Knex query builder actually constructs queries like that. So it's doing its best to keep us from introducing inadvertently any kind of a harmful attack vector into our code. But again, the principal reason that you might use either toString back here or toSQL up here is to simply get some information about what's going on in the query, verify that it's doing what you think it's doing, or just to generally debug the query behavior. So these are both ways that we can get information about the query that's going to be run against the database, but so far all we've seen is either the query string itself or the query plus the additional details. So let's take a look at a little more detail on how the select statement actually works, and now we're going to actually do stuff that hits the database. So here's a simple query. Again, we're using that Knex object. We're doing a SQL select, and we are getting our select from the country table. And then the where clause here, in the past we have just seen two arguments to the where clause, where the first argument was a column name and the second argument was a value that we were matching in that column. And by default, if you use just those two arguments, the where clause will basically compare those two things for equality. So if we go back to this example, where country, comma, Thailand, basically what that's going to do, as we can see here from the query that gets generated, is doing an equality comparison between country, and Thailand will eventually be bound in place of that question mark. So with just two arguments, Knex gives us the common case. We're going to just do a comparison for equality between those two things. Does this country column from the country table match the value Thailand? And if we want to do more complex kinds of comparisons in our where clause, we can use a 3-element form of this. So this where clause is going to use the country column, and it's going to use the like comparison rather than an equality comparison, and it's going to compare against this pattern T, and the percent sign is a placeholder for some arbitrary number of characters. So essentially what we're saying is let's match all of the countries that start with a T. So it's a T followed by any other characters. And you can see here, I've finally derived some output. We can see that we're getting the country names that start with T's, and we're also outputting an ID value here. Well, where's that coming from? Let's take a look in a little more detail what's taking place in the query. So far what we've seen is that the select and the from and the where are just going to generate SQL that's going to eventually be delivered to the database, but we haven't seen it actually result in a query yet. You can see here from the next method call, the .then, that this looks a whole lot like a promise that's being asked to be fulfilled. And that's exactly what's taking place. The value that's returned from this last part of this select portion of this chain of calls is a promise. And the then forces that promise to resolve. So it's at that point that the query is actually sent to the database. The database is going to process the query, respond with its result set, and send its values back. Again, this is all taking place asynchronously, which is why we're using promises. So when the database comes back with its set of rows that are the result set from this query, it's going to be passed into the fed arrow function that's part of the then method. And those rows that are returned from the database are going to be returned as the argument to that fed arrow function. Again, fed arrow function, to the left are the arguments, to the right is the function body. And in this case, the argument that gets returned is a list or an array of objects, and those objects correspond one-to-one to the list of rows that were returned from the query itself. So we thereby have access to the information that was returned from the database in this rows array. Now inside of our fed arrow function, we're going to basically just print these things out. So I'm going to use the rows array and the standard JavaScript iterator, right? So for each says, for each of the elements in this array called rows, call a function. So here's a fed arrow function. And what's going to happen is we're going to pass to that function each of the rows. So you can see here I've got another parameter called row. That's the argument to this fed arrow function. And then the function itself is just a single console.log statement. And what it's logging out is row.countryID and row.country. You might infer from this then that because we're able to take that row variable and apply the .countryID and the .country, that row might itself be an object of some kind, and you'd be correct. Essentially what happens is that when the query result is returned from the database, Knex takes the individual rows of the result set and converts each row into an object where the keys of that object correspond to the column names of the result set. So for each of the rows, because we're asking for the country ID and the country, we see that we have access to the country ID under that key within the row and the country name itself under that key within the row. And that's why we see these two values showing up in each of the output lines. So the first time we iterate over this for each, we print out country ID 92, and that turns out to be Taiwan. Country ID 93, country name Tanzania. So you can see that we're getting a little bit of advantage by using Knex already, not only in the fact that we're able to construct a query quite conveniently and in a way that's independent of the underlying database, but Knex is also kind of helping us a little bit by giving us back something that's quite convenient to access inside of JavaScript. Let's take a look at an example that hopefully will give you a little bit more insight into what's actually being returned back from the Knex library. So here's another query that's going to select rows from the film table. This is a little bit of a different syntax rather than having a Knex.select and then a .from film, which is what we were doing back here where we've got a .from clause, we can simplify that a little bit. It's just kind of a shortcut that Knex provides where we can name the table that we're trying to query from as an argument to that Knex object itself. Either way is totally valid. So we're going to select from the film table, and then the select statement itself, or the select clause, is going to select these specific fields now from the result set. In the past, we've been using select, which is an empty argument list, which basically defaults to select star. So it selects all of the fields or all of the columns in the result set. We can call out specific columns that we want to have come back by listing those column names as arguments to the select method itself. The next thing I'm calling here is a limit, and this basically just says, give me this many of the rows from that result set that would have otherwise come out without the limit, and I'm just asking for 10 rows. Now the only reason I'm doing that here is to keep the result set on the slide. I don't want to have it sort of spill off the bottom of the page. So don't feel like you always have to do a dot limit there unless you really only want the first 10 rows of the result set, but that's really why I'm doing it here. Up to this point, again, we've basically just been telling Knex how to write the query that we want it to run. So at that point, we've created this select film ID title release year from film limit 10. As soon as we do something that's going to sort of force Knex's hand, if you will, the query is actually going to get executed. So by calling the .then at this point, we're basically saying I want to have the promise resolve to something, or I guess if the query fails, we might also see a rejection of the promise. But the .then kind of triggers the behavior that causes Knex to go out to the database asynchronously, wait for the query result to come back, and then package it up as an array of objects. Then when the promise resolves successfully, the function that we provide to the .then method is going to be invoked. Again, here's our fat arrow function. We're going to get an array of rows. And in this case, rather than iterating over those things and formatting them a specific way like I did in the last example, I'm just going to log out that exact array. So you can see here in the output that we've got, so here it's obviously an array. There's an open bracket and a closed bracket. And then within the array, each of the elements is delimited by curly braces. So from here to here, for example. And you can see that inside of those objects, we've got key value pairs like we'd expect. So the first key is film ID, which corresponds to the film ID column, and its value is 98. And then title is the next key, and there's the title of that movie. And then release year is the next key, and there's the release year. So you can see that that's the structure, or the type of structure that was underlying the previous example. And when I went in and asked for row.countryID and row.country, it was looking up those particular values by the country ID and country key that corresponded to the column names in this case, the country table. Here we're seeing the column names in the film table and just dumping them out directly. But the key thing here is that the result is an array of objects. Okay, it's ordinary JavaScript objects. They're not instances of classes or anything like that, as we'll see later when we start talking about the object relational mapper. But already, as I said, it's quite simple to refer to the contents of these rows, to access the individual elements of each row by just using the column name as a key. Up to this point, we've been kind of focusing on the select statement itself. Now let's drill down into some of the other of these methods and understand a little bit more detail how they work. So first of all, let's take a look at how we can create where clauses in our queries. And we've already mentioned this, but if we use if we use a dot where and we just give it two arguments, the first argument is the name of a column, and the second argument is the name of a constant, or is a constant, that's going to be compared against that column with an equality comparison. So this query is going to look for film ID, title, and release year in the film table, but it's going to add this additional constraint that it's only going to give us back values in that result set where the release year is equal to 2006. Again, I've got a little limit clause in here to shorten down the list of rows in the result set. And as in the previous example, I'm just console logging those rows directly so you can see the underlying structure. So again, it's an array containing objects, and those objects have the attribute names as the columns and then the corresponding values from that row. And you can see, of course, that all of the release years that we're getting are 2006. which is evidence that this where clause is being observed. It's also possible to do a conjunction inside of our where clause. So oftentimes in a where, you'll want to say where A is equal to B and C is equal to D. And the where allows us to do that fairly directly, whereas instead of just giving individual arguments to the where clause, if we pass it an object, it assumes that we're going to be doing a conjunction. We're going to use an and comparison in here. So the keys of this object are the field names, and the values of the corresponding field names are the value we're going to compare to for equality again. So essentially what this is going to do is select these two columns from the film table where the release year is equal to 2006 and the length is equal to 120. And then I've said limit this to 5 and printing out the result. So we see the film ID and the title of these first five films that satisfy these constraints. They were released in 2006 and they also have a run length of 120 minutes. Another variation on the where method allows us to do things other than equality comparisons. The previous examples we've seen, except for that like example that we looked at previously, all do equality comparisons. If we want to do a comparison with a different operator, we need to add a third argument to the where clause. So where length, again, that's still the column name, and the value we're going to compare it against is the final argument. But now this new argument in the middle is giving us the comparison that we're going to do. So this is going to say, give me the title and the length from all films whose length is greater than 150 minutes. And then here are the data that come back, again limited with that limit 5. So you can use pretty much any of the operands that you want to use in there for comparison, less than, greater than, so forth, to do more complex types of selection of the rows that survive into the result set of the query. We can also do multiple of these, right? Previously, back here, we saw that if we just wanted to do simple equality comparison and we wanted to and these things together, we just list them as an object, and the underlying Knex code converts that into a equality comparison with a conjunction. If we want to do something that's a little bit more flexible, we can actually invoke that where clause multiple times. So here we're saying I want to get the title and length from the film table where the length is greater than 100. And then I add another where clause that says I also want to constrain this to have length less than or equal to 150. And notice here, just so that we can kind of see how this caches out in terms of the SQL query, I'm calling toString to store the string value of that SQL query there, and then logging it out to the console. So you can see here we've got select title and length, right? That's what's coming from here. From film, there's the from clause, where length is greater than 100 and length is less than or equal to 150. So Knex was smart enough to recognize that we had multiple where clauses, or multiple invocations of the where method, and stringing them together with an and. If we had a third where clause, there'd be another and then the clause itself would show up next. So we can stack up as many of those as you'd like, and because this 3-argument version of the where method is in play, we can use any kind of a comparison that we wish in the where clause, or in the individual conjunct of that overall conjunction. Now we also might want to do an or. Well, it turns out that ands are quite a lot more common in practice, so the Knex syntax makes that the easiest. If we want to have ors in our where clause, we have to use a slightly different method called or where. And so this is otherwise pretty much similar, except that we're now asking for movies that are shorter than 60 minutes or greater than 180 minutes. So again, we're just printing out the SQL, and you can see here that we've got now select title and length from film where length is less than 60, that's from here, or length is greater than 180. You can see here that these lines are wrapping around, and that little symbol is just an indication that the line is continuing on the next line. So we can do ands and we can do ors using or where. All right, let's take a look at how we do aggregation using Knex. Just to kind of refresh your memory, the idea about aggregation here is that in many queries, we want to be able to do some sort of a collective operation on the results of the query. for example, if we're trying to total up our sales information across the country and have like total sales in each of the 50 states, we're going to need to somehow group together the sales figures for each of the states and then report them in one result set where it lists basically just the state and then the dollar figure for that state's sales. So that's going to be derived from probably gajillions of other transaction records that would say, we sold $10 worth of product in Indiana, and then we sold $20 worth of product in Michigan, and $40 worth of product in Indiana again, and then $45 worth of product in Indiana, and so forth. So we've got all that individual transaction data, but what we want to get is a total, and we'd like to be able to report that by state. And that's what we're going to get to here in a second. But let me first offer sort of a motivation for how this might play out. So here's a statement or a query that doesn't actually make use of this aggregation mechanism, but I wanted to just kind of show you an intermediate step along the way. So here's a list of the first names of the actors in our database. So I've got a Knex query. I'm selecting just the first name field from the actor table. This clause is new. It's the order by method, and it's going to just add an order by clause at the end of the SQL statement that's being generated to cause the results to be sorted by first name, and we'll come back and revisit that in a bit. And then I'm limiting it to 10 rows just to fit it on the page. And then I'm doing two things here. I'm going to print out the query itself, okay? So here, at this point in the code, all I've done is construct the query, right? I haven't called a then anywhere to trigger the query's execution. So I can access that query variable and say query to string, and that's going to convert it into a string. And you can see here at the beginning of the output, there's the select statement. Select first name from actor, order by first name, ascending is the default, and limit it to 10 rows. So that's what's coming from this console.log. And then I want to actually execute the query and see what comes back from the database. So I'm in the last line here, I'm saying query.then, and then that's going to cause the query to be executed, and then it will pass the rows that are returned from the database into this fat arrow function, and I'll just log them out to the console. So you can see here's the 10 rows that came out of that query statement. This turns out to be a really handy way to kind of debug your code if you're getting confusing results from your database. Do both the toString and also run the query and see what you get back from it. At any rate, what you can see here is that I've got two Adams in my database. Just one Al. I do have an Alan. I've got a couple of Alberts. I've got a couple of Angelas and an Angelina. So this is interesting in that I can figure out, well, how many or what are the different first names in my database, but it's kind of redundant, right? I've got multiple rows that basically show the same thing. It might be more interesting for us to be able to say, well, how many actors have Adam as their first name versus Angela, for example. And that's the kind of thing that we can do with an aggregation operator using group by. One way to think about what group by does is to either actually run this kind of a query here, or just imagine what this query is going to look like. I've got two rows here that are going to say Adam, and then two Alberts and two Angelas and so forth. Essentially what a group by is going to do is kind of squish down that intermediate table such that it's going to remove all of those duplicate names, and then we can also ask group by to count how many there were. That's illustrated here. So we're sort of squeezing out the common rows, and then we also can apply aggregate functions like counting the number of rows that were squeezed out. Here's the query. Again, I'm selecting just first name from actor, and now I'm saying I would like you to group those rows by first name. That's going to say which of the columns of the result set are going to get squished down. Okay. And in addition to that, I'm also calling this new method called count, which is going to say I want you to count the first names. Let's come back to this as clause here in a second. But you can see here in the output of this, the count is resulting in this syntax, count first name. So this is maybe the first time you've seen anything more complex in the select clause than just a column name. But the arguments that go to select can actually be fairly arbitrary expressions. You can even use a select statement as like a 4-function calculator to add and subtract, multiply, and divide. But one of the functions that you can use in those expressions in the select statement is this count. And that's basically just saying, I would like you to count by the first name the rows that are in this query. And furthermore, I would like to, instead of having to refer to this as count first name, that whole awkward looking string, I want you to give it a little bit of an alias for me. So I'm going to ask for this result as a result set where the column that's carrying the counts of those individual names is going to be called name count. And you can see that that syntax is what's being interpreted from Knex based on the contents of this count method. So that thing is basically being translated into count first name, which is the correct syntax for the count in SQL, and it's also being given this alias so we can refer to that more easily later. And then the group by tells us what we're grouping on, which of the fields we want to sort of squish down, and you can see that that shows up here in this SQL as just group by the name of the column. The order by again is going to order by the name count, and it's going to order it in descending order. Now this is really the reason that we're going to the trouble of creating an alias for our count field. If we hadn't done that, we would have had to say something really weird looking like order by count first name, essentially replicating this goofy expression. But instead we can say, okay, let's evaluate that expression to get those counts, but let's call it name count. And that allows us to use name count as an alias in our order by method. And then we're specifying descending order instead of ascending by default. Now we can see in the result set that comes back, I'm doing the same thing here, printing out the query and then executing the query and printing the rows that come out. And you can see what happens. We get first name Penelope and then name count, right? That's what's coming from here. And then the number. There's 4 rows that have Penelope, 4 rows that have Kenneth, 4 rows that have Julia, 3 rows that have Russell, and so forth. So if you kind of go back here again and think about this, this is kind of the underlying query. We're asking for all the first names. We're doing the same thing here, right? Select first name. There's no where clauses here or anything like that. But instead of just printing out the first names one after the other and having a bunch of duplicates in places, we're using group by. Again, it's not really the technical term, but we're squishing those rows together along the column that's mentioned here in the group by the first name column. And then we're adding a second expression to our select statement that's going to count the number of rows that got squished out. And that's what gives rise to the name count. Note also that there's other aggregate functions that are available to us. We're using count. We could also get the maximum value, the minimum value, the average value. And to my earlier example about coming up with the total sales, say, in each of the 50 states, we could select out the state name and the sales number for each individual transaction, group by the state name, and instead of using count in the aggregate function, which would basically just tell us how many transactions were made in each state, we can use sum, and that will total the values of those transactions, of the individual transactions, to give us the total in each of the states where there were sales. Finally, let's take a look at how we do joins in Knex. So we're familiar with the notion of a join, that we're going to connect together 2 tables where we have common fields, a foreign key, primary key kind of interaction. So I've given here a little bit of a picture of the structure of this DVD rental database. I've got 3 tables, the first of which is the film table, and you can see that it has a primary key of film ID and then other columns like title and description and release year and so forth. I also have a category table, and it's got a primary key that's a category ID, and this is like drama, comedy, science fiction, right? It's the category of the film. And its principal field is the name field. Now, in this particular database, the database architects have decided that we will have the possibility of a film having multiple categories. So it might be a romance and a comedy if it's a rom-com, or a science fiction thriller or something like that. And obviously, so for one film, we might have multiple categories. For each category, of course, we're going to have a lot of films, presumably. So for the sci-fi category, we're going to have a whole bunch of films. So in order to get that many-to-many relationship between films and categories, we need to have an intermediate table, usually called an associative table, or a join table in some cases. I prefer associative. And what the associative table does is it has two values. In this case, we're trying to connect together a specific film with a specific category. And we'd like to be able to do that in multiple ways. So the film ID here is a foreign key that refers to the primary key of film. And category ID is also a foreign key that refers to the primary key of category. So by adding a single row to this film category table, we can say film X has category Y, but film X also has category Z, and film X has category A, and then we can have multiple films in the same categories in any combination that we choose. So in order for us, for example, to get a report of the films and the films category, we need to be able to do some joins here. We've got to be able to join the film table with the film category table and film category with the category table in order to determine which categories are associated with a particular film or vice versa. Okay, so that's the data model that we're going to use for these examples. And here's a query that does what we just suggested. So we're going to say, again, we're going to look for the title. That's going to come from the film table. And then the name, and that's going to come from the category table. Now, in this case, we're just able to list the column names because if we go back here to the data model, the only place where we have a column called title is in the film, and the only place we have a column called name is in the category. If we had duplicates of those, for example, if we had a film name instead of a film title, we'd have had to been more explicit and said something like film.name in order to distinguish it from category.name. So in SQL, we use the dot to separate the table name from the column name when we need to be able to disambiguate duplicate column names. In this case, we don't have to do that because we only have one place where there's a title and one place where there's a name. Now, when you're doing joins like this, I kind of imagine a sort of a sequence going on here where I'm kind of navigating from one table to the next. So if I imagine myself starting out with a film, what I want to do is eventually get over to the category table to find out which category that film might be connected to. But I know because of the nature of the data model that I've got to get through this film category table that gives us the many-to-many relationship between films and categories. So I literally think about, okay, I'm at the film and I want to get to the film category because that's the next step along the way toward the category table. Well, how do I get there? Well, I want to join together film and film category using the film ID from film category matching the film ID from film. And that's what's reflected here in the syntax for doing an inner join with Knex. So I'm starting out by doing a query against the film table. Once I have that, I'm going to do an inner join. And I'm going to inner join to the film category table, right? I'm going from here to here. In order to do that, I've got to connect together two fields. I've got to know that the film ID in the film table is got to match up with the film ID in the film category table in order to get the primary and foreign key associations to work properly. So I've got film.filmID and film category.filmID. So by just basically giving that information about how these things are going to connect together, I'm giving Knex sufficient information to be able to write the underlying query. So it's going to say something like select title, comma name from film, inner join film category on film ID equals film category film ID. So at this point in the query, I've now navigated my way kind of from the film to the film category, and I want to go from there to the category itself. So I can just go ahead and do another inner join. So this from statement basically gives us a result set that just has that film table. Now I'm creating kind of another intermediate result set that includes elements of film and elements of film category. So I'm going to take that intermediate table and I'm going to do another join with the category table. So I'm joining to category, and then again I have to tell it the name of the two columns on either side of that relationship. So film category.category ID and category.category ID. Notice that these have to be table name.column name because there's two places where I have category ID, just like I have two places where there was film ID up here. So we're matching this category ID with this category ID to cement the relationship between the film and a category that film is in. As I was working my way through the example here, I discovered that there was some problems with the code, and I have repaired those, and this is the current correct version of the code that we were looking at before. We basically have explored the code down to this point where we've done the select, the from, and then joined the other two tables together. But that's pretty much all we want to do for this example. I'm going to put in a little limit here to keep the number of films in the output short. But basically then all I'm doing is a simple for each again, iterating over each of the rows, and those rows contain a title and a name because that's what I put in the select clause in the query itself. So let's take a look at the output from this. And we can see that we've got not a lot of great punctuation here, but you can see the title and then the category name. So Academy Dinosaur is a documentary, Ace Goldfinger is a horror movie, another documentary, another horror movie, family film, and so forth. So this is the title of the film, and this is the name of the category. And again, back to this illustration, we had to do two inner joins to connect films to film categories and film categories to categories in order to be able to extract the title and its corresponding category name. Okay, so a little bit more advanced example. Let's, instead of just printing out the films and their categories, let's see if we can't figure out the most popular categories. So here's a related query where now we're going to kind of come up with the list of category names and then figure out how many films are in each category. But rather than printing out the details of the category and the films, we're going to do an aggregation operation to squish things down by category name and then end up with a count of the number of films in each category. So here's the category name is what we want to fish out. And I want to do aggregation here as well. So just like before with the group by, we're going to do a count on the category, and we're going to give it a convenient alias that we can use later on in the query. Then these intermediate lines are quite similar to what we've seen before. We're going to join film to film category to category using those intermediate foreign key, primary key relationships that we saw before. Then we're going to do a group by. So we're going to squish things down by the category name, right? That's the first of the two columns that are going to be output by the query. And then we're going to make use of this alias that we had created for our category count and use that as an order by that's going to order by category count in descending order. So the most common category is going to appear first, and then less common categories below that. And just like before, I'm going to print out the query itself so we can kind of see what Knex is doing on our behalf. And then I'm going to run the query, right? I've stored this query result in this query variable, and then by invoking the .then on the promise that's stored there, I execute the query and I get back a list of the rows, and then I'm printing them out as you see here. So the output from this guy, here's first of all the query itself, and you can see that there's quite a lot of stuff that Knex is doing for us to get all the punctuation right, to get all the quoting right. The important parts that we can see here, these are the two columns, category.name, and then the count of the category with this category count alias. We're going from film, we're interjoining with film category, we're interjoining again with category, and then grouping by category, and then ordering by that count value from up here in descending order. And you can see the most popular category is sports with 74 films, followed by foreign films with 73, family films with 69, and so forth going down. And obviously the counts are themselves being sorted in descending order because of the order by clause. So that's a little bit more of an elaborate example of how we can leverage Knex to build these types of queries. You can see we can do some quite sophisticated queries without a whole lot of monkeying around. In particular, we don't have to know all of the gory details of a specific implementation of SQL on a particular database management system. This same code, although it took us a little while to get here and maybe it's not trivial code, but this same code should work on pretty much any of the databases that are supported by the Knex Query Builder without any modification at all. Knex itself will adapt the SQL that it generates based on these function calls to create the SQL that will work on any dialect of SQL that's supported by the library.